All right, so here we're going to find the 8th term for each of these geometric sequences. So for this, we're going to rely on two equations that I like to refer to, where we have the an term being equal to the am term times r to the n minus m power, and the common ratio r being equal to the n minus mth root of the an over amth term. Now, just depending on what information you have in the problem and what you're trying to accomplish, like what your goal is, you may need one or the other or both or neither, you know, but these two are really just all you need to solve virtually any geometric sequence for an nth term. Now, in this case, we're not given two terms in a row. See, we're given A3, so we're like starting with 12. We don't have A4, we don't have A5, and we have A6 as 96. So we have to figure out what, you're multiplying by each time. Now, you can always guess and check, and a lot of times the homework problems, the values are easy to figure out. But let's not rely on that, because in real life and when you get into like more rigorous math, if you do, it's not going to be that simple. So we're going to rely first on this equation to find r. So we're going to set r, common ratio r, equal to n minus m. So we'll make n equal to 6 m3. And we're going to take the 6 minus 3 root of a6 over a3. Evaluating this, we'll have then the third root of 96 over 12, or the third root of 8, which essentially is the number that we raised to the third power to give you 8. And that's going to be 2, because 2 to the third power equals 8. 2 times 2 times 2 will be equal to 8. And check, to make sure that this makes sense. So multiplying 12 by 2, we're going to get 24. Multiplying 24 by 2, we get 48. 48 by 2, we get 96. And then so that then checks out. So we know we have the right ratio. So now let's find A8. So A8 will be equal to AM, and let's keep AM as A3 times our common ratio R, so times 2, raised to the n minus m power, or in this case, 8 minus 3 power. And let's just evaluate this. So A3 is 12, so 12 times 2 to the 5th power. Two to the 5th, 2, 4, 8, 16, 32. So 12 times 32 is 384. And there you go. So let's do one more. Let's look at the next problem, 10, where we have that A15 equals 100, and that A17 is 25. So again, we're not given two terms in a row. So we want to find, this pattern. Like if we start with 100, we need A16, and then A17 will be 25. And again, you can always guess and sometimes figure it out, but let's, amuse ourselves like we can't figure it out just mentally. So then we solve for r, make the common ratio r equal to n minus m. Let's make n 17. And let's make m 15. So the 17 minus 15th root of A17 over A15. So the second root of 25 over 100, or the second root of 1/4. The second root is just a square root, because the number raised to the second power is, it's a square root essentially. And then that means r will just be 1/2, because 1/2 raised to the 1/2 times 1/2 will be 1/4. 1/2 to the second power is equal to 1/4. And again, let's verify to make sure this is correct. So if we take half of 100, we'll get 50. Half of 50, we get 25. So we know we're good there. So now we can use our equation for an. So to find a8, we're going to set a8 equal to am. So we're going to set am, let's just make it a 15. Times r, so times 1/2. To the n minus m power, so that to the 8 minus 15 power. A15, 100 times 1/2 to the negative 7th power. Now remember your properties of exponents. 1/2 to the negative 7th power is the same as 2 over 1 to the positive 7th power. So this will just be 100 times 2 to the 7th. 2, 4, 8, 16, 32, 64, 128. The 128 over 1 are just 128. And so 128 times 100, you'll get that A8 will be 12,800. 12,800. Now, the only thing is, this could be positive or negative, because technically we could say that the second term could be negative 50. So we can say that their common ratio is positive or negative. Again, sometimes they'll say assume r is positive, but just in case, if it didn't say that, we would argue that this could be positive or negative. Positive or negative 12,800. Yeah, it doesn't matter. And so, yeah, that's it. There you go. So I hope that helps. I'll see you guys in the next video.